Wait, so if I do the thing at all. All right. So this is the I guess introduction to AI/ML meeting. So how many of you are freshmen? Raise your hands. Okay, a lot of freshmen. Okay, so how many of you want to learn more about ML? I hope all of you, since yeah. Okay, so I guess the point of this presentation is essentially to help you learn, okay, what the hell is the field all about? Yeah, what's going on? So let's get into it. So what I'm gonna do is just go over, give you an overview, and I'm gonna talk about the types of AI and its applications, and also some important terms you're gonna come across if you're gonna get it more into the field. Okay. So what is AI? This is my Yap session now. You're trapped with me now. Okay. So basically, we keep hearing like all this crap in the news about like AI this, like generative AI in business, right? AI generated art. Okay. But like it feels like the meaning of AI has sort of lost its meaning. Like what the hell is AI? Right? You could like apply it to anything, right? Because we call like video game agents like AI, right? But we also call large language models AI. So what really is an AI? Personally, I don't use the term AI ever. What I use instead is machine learning or deep learning, right? Or ML. So usually when most people talk about artificial intelligence nowadays, they're referring to deep learning. Okay, so I'm gonna get into it in a sec. So here are the applications of AI. I just selected some for you, which are natural language processing, computer vision, and agents. So what we can say is that machine learning is just a subfield of artificial intelligence, and deep learning is a subfield of machine learning. Okay. So what is machine learning? Machine learning is the creation of algorithms that can learn from data without human intervention, right? So what we essentially do is we create mathematical models that can be we can easily put data into. And then these models essentially learn from that data and can recognize patterns that we humans can't. This is incredibly useful for basically anything, but as long as we have the data that we can feed into it, we can make useful models. And deep learning, as I said, is just machine learning, but more sophisticated. So typically, deep learning models will require more compute or more time to run and train efficiently. So here's the most important thing. It's just data in, data out, right? If you have garbage data, and if you feed that into a model, you're going to get garbage results. It doesn't matter how sophisticated your model is. It's just going to be garbage. So really, what we can think of machine learning as a field is essentially learning how to take data, good data, and put it through a mathematical model and transform that data into something useful. So what is natural language processing? Can I get a show of hands? How many of us have used ChatGPT in the last year? Okay, so basically everyone, right? I assume so. You're coming to this club. Yeah, that's natural language processing. I mean, that's what you can think of. Natural language processing is the use of computer algorithms to analyze human language, right? We're using machine learning to create useful information from human language. And we can kind of think of it it used to be thought of as the intersection between computer science and linguistics. Now it's basically just computer science. No one cares about the linguistics. So the applications are text generation. I mean, you've seen that everywhere nowadays. Everyone's talking about ChatGPT. Sentiment analysis. So a lot of sentiment analysis is used, I I guess, like for reviews online to see how people are thinking. And translation. I mean, one of the earliest well-known uses of NLP was Google Translate and other translation software, but we didn't really think of it. So what we have on the screen is just a sample conversation with Claude.ai. Yeah, so here's computer vision. Computer vision, as you can probably guess, is using algorithms to find useful information from images. So it's just discerning information from visual media. As we see here, this is an example of a car in San Francisco that's trying to, I guess, identify what are the useful things in an image. So how many of you have been to SF recently and saw one of those goofy ass cars? Yeah, they're something, but they're a great example of computer vision because in real time they have to analyze like a ton of imagery and find, okay, who's a person, right? Who's a car? What's a traffic light, right? So we have to segment or individually identify useful things or features in an image, like, okay, who's a person, right? That is an application of computer vision that is basically useful for everything, right? Medical diagnosis, right? If you use the face unlock on your phone, that's computer vision. And as I just said, self-driving cars. Yeah. Okay, so here's another question. How many of us have been on social media? Like, okay, how many of us have been on Instagram in the last, like, yeah, okay. How many of us have used Amazon? Yeah. Okay, so if you've been on the internet within like the last ever, you have interacted with AI agents. So what AI agents are is that they take information from their environment and make decisions. So they do tasks in real time. So what does that mean? Usually an agent model is trained on some sort of data, right? So let's take Instagram, for instance, right? A decent agent model will, what we call the algorithm to recommend crap to you. It'll be pre-trained on some useful data, what they think that like the broadest demographic of users would want to look at. And then it recommends that crap to you. And based on what you engage with, right? Based on the observations from the environment, which is you, they will recommend like, I don't know, some reels or brain rot to you, whatever you're clicking on, right? So yeah, so recommendation systems like on Amazon and Instagram are an application that I just talked about. And also autonomous vehicles, as I just said, they do tasks in real time. And gaming agents, so if you've seen a recent application of it being used on Minecraft, that's an example. And also robotics, which collect information in real time and can move. Okay, so here's some important vocabulary that if you want to get into the field, you're probably going to run across it very, very, very often. So I'm just going to get into it here. So these are basically two types of learning that you're going to come across very frequently, especially in more classical ML or more basic ML that we're going to cover this quarter. So supervised learning is essentially just training machine learning algorithms that require data to be labeled. So a lot of the time, right, if you want to classify between, if you want an AI model to classify between cats and dogs, you're going to have to label that data between, okay, what is a cat and what is a dog? Because the model will never know like by itself, right? It has to learn from the data. And unsupervised learning is just training without labeled data. So what is that? Okay, so let's say you have a bunch of dots on a chart, right? Like, imagine you have a bunch of dots on a chart, and let's say you have an algorithm that can try to find the average between all of these dots, the average line. That is called linear regression, and that is unsupervised learning, or an example of it. Okay, here's another piece of vocabulary. as I've talked about this, you probably learned what a model is, but a model is just an algorithm that can make predictions based on learned patterns from data. A machine learning model is basically any algorithm, right, that's made using machine learning. And training is when you force a model to learn patterns from data by minimizing an error function, right? So another term, what is an error function? An error function is just a measure of objectively how bad or how inaccurately a model classifies data or how badly it performs. So what it does, it tries to minimize that error function, okay? But the thing is, it's not so simple because what we have here is a 2D graph of an error function, but a lot of the time, an error function, especially with much more sophisticated models like ChatGPT, the error function might be like, I don't know, 1,000 or so dimensions, right? So we can't even visualize 4 dimensions. So what we need to do is just use math or gradient descent to find the minimum of that error function, right? And then we can minimize how crappy it is. Classification, as you've probably seen, is just a model predicting the class and type of a thing. And regression is, as I said, a model looking for relationships between multiple variables. In this instance, this is linear regression, finding a line that best approximates a bunch of data. Okay. We're going to look at a silly little video that I thought was funny.
It's ready.
Please, God.
What do you say if I told you there is an apple on the mountain? That's that part. Just demo it. Okay. Let's start with a hot dog.
Jinian, my beautiful little Asiatic friend, I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves. You'll never feel exposed again. Right. You guiltful little pizza. Let's do pizza. Okay. Pizza.
Hot dog?
Wait, what the fuck?
And
That's it? It only does hot dogs?
no, and a not hot dog.
All right. Alrighty. Wait, how the fuck do I? Oh my God. Sorry. Okay. So the thing is, that was binary classification or an example of it. So what I don't know, the Asian guy did was essentially find, okay, is it a hot dog or not a hot dog? Which at the time was pretty impressive, right? But you know, it's not that useful. What the other guy was hoping for was multiple classification or multi-class classification.
It's ready.
Oh my God. Oh my God. Okay. Yeah. So this is a binary classification. You just distinguish between 2 classes, right? Cat or dog, hot dog or not hot dog. You get it. And multi-class classification is learning to classify objects, okay, or pieces of data between 2 or more different classes, which is pretty good. Yeah. So if you want to get more into, I guess, ML or something, and you don't really know where to start, then you could try Sky's No Limit. It's our fun little competition. I did it. I thought it was very useful. So just saying. There's also stuff online. You've got like StatQuest, DTL.ai, Fast.ai. These are all like resources that you can use to self-learn about like a lot of stuff in ML. And honestly, getting involved on campus is probably your best bet. So like, you know, I'm assuming a lot of you are CE or CS or whatever the hell. So you're probably on the Basket newsletter. Whenever you see something related to AI or something, show up, just show up. I mean, if you guys are freshmen, you have hella time. So just do it. Also, you can try to get involved with campus research. And yeah, also start your own projects. Starting your own project, if you can just motivate yourself to do something, even if it's completely useless, you'll have learned a lot by the end of it. So yeah.
Yeah, so more about sky's no limit. If you guys want to make your own hot dog or not hot dog classifier, then this is a competition where we basically teach you, even if you're a beginner, on how you can make an AI. We basically have workshops every Friday. So next one this Friday is happening at 1:30 to 2:30, and there's also going to be a second one 2:30 to 3:30. Where basically you have to make the AI for our competition. It's not like a pre-made AI. It's an AI you've coded using PyTorch or another framework similar to that. And it has to be under the theme that we're going to reveal right now. Drum roll, please. Written in the stars. That's our theme. And you're free to interpret that as broadly as you want. So maybe you do something about stars, identifying constellations. Probably, honestly, now that I think of it, the hot dog classifier probably wouldn't fit under this theme. Written, you could talk about maybe something to do with natural language processing, though I'm going to say natural language processing is a difficult field and don't expect to make ChatGPT. You could do something to do with prediction, right? Written in the stars means something is foretold to happen. If you do something with oracles, something similar to that, just think about it. And again, we have a workshop this Friday. And if you want more information about that workshop, where it's happening, what time, that's on our Discord. Our link tree also has our Discord and our Instagram, where we're going to be posting updates. We also like you guys to give some feedback on this presentation. Just QR code right there.
So yeah, actually, the main thing to say is, does anyone have any questions? Wow, no questions.
No questions. Really, 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 really. Please. Literally anything. I'm back. Yes. Yes. So finding a smaller picture within a bigger picture. That's what you're doing.
I mean, it's a good start. I feel like there might be more traditional computer vision techniques you could use for that. I know for fusing images, there's some algorithm Google Maps actually uses on their Earth view, but I'm not sure. I forget what the algorithm was called.
Okay. Anything else? Come on. Yeah.
Python.
Yeah. I mean, just have PyTorch, Python, PyTorch.
If you guys also want, you can start making a group, right? Reach out to people in this group, that's what
Be social.
ideas. At the workshop, I'll be talking about what makes a good idea and what makes a bad idea for AI. So maybe think of a couple ideas, find a data set, and I can tell you guys what I think of it.
And before we move on, I should note that teams are max of 4 people.
All right.
Just yeah.
Do you have something?
Yeah, they'll be recorded. Yeah, they'll be recorded.
Yeah. So if you have like a schedule conflict or something, the slides will be recorded, but
I'd say for the workshop, it's a little more hands-on. So most of the utility is going to be like being there and asking us questions. But I'll record it.
Yeah. I could be here for like 2 hours and not be done. But what do you have any specific questions about computer vision? Sure.
So this is just going to be a really quick rundown. If you don't understand this, that's okay. Also, actually, I should note, who here, raise your hand if you understood everything from this presentation. It all made sense. Okay, maybe a couple of people who are sort of raising their hands. This is still an amazing presentation. Raise your hand if you got maybe 50% of it. Okay, that's almost everyone. Raise your hand if you learned something and found this valuable. So I just want to say, like, this presentation is an overview, this one specifically. And if you don't understand all of it, if you're only maybe getting like 25%, but you're still learning stuff, that's good. I don't want to scare people away with some of this stuff is a little more confusing. But I wanted to just point that out, to like look around. There were like maybe only a couple of people who got everything from the presentation. And that's generally to be expected. So quick thing about computer vision. Generally, this is taking in some kind of image and giving some kind of classification output. That is the very simplest example. So if you end up doing something like this for Sky's No Limit, what you guys will probably do is get an image, let's say, cat, dog, bird, et cetera. That's going to be tossed into a neural network, specifically a convolutional neural network, which is essentially one that is good at processing images. I'm not going to go into it because that's a lot of stuff. And then eventually it'll get to some kind of, that's the data in, image, data out will be some kind of prediction of what it is. That's kind of the simple, basic basis of computer vision as a whole. Yeah. Any other questions?
Our next lectures will be going on like more specific topics. That's kind of an overview. And then our next ones will be on specific algorithms within AI.
Yeah. Yes, in the back. On the Discord, yes. I think they should already. There's a link to the drive in resources. I think, yeah. There's a link to the drive in resources, which has all of our recordings and all of our slides. We can also start posting the specific slides along with the recordings. There's a specific recordings channel that has like the video recording of all of this. But if you look in the drive, you can also find the slides. And if you want, we can also post the slides with the recordings. Yeah. Any more hands? Scanning, going once, going twice. All right. Well, thank you everyone for coming. Yeah.
Yep. Please socialize amongst yourselves if you want. It's a great way to make friends. I don't know.
And I hope to see you guys at the Friday's workshop and next week's instructional meeting. Have a good day, everyone. Thank you for coming. That was amazing. That was perfect.